All right, we're going to talk about modeling with exponential, logarithmic, and quadratic. So the first thing I have up here is I have our exponential. So if you remember, our exponential function is y equals b to the x power. Okay, so traditionally it's going to look something like this. If as long as b is greater than 1, if b is between 0 and 1, it's actually going to go the other way. It's going to look like this. Okay, so the first thing is when I'm graphing exponential functions. Okay, so I want to graph y equals 2 to the x. So a lot of times what we want to do is we want to pick some negative numbers, 0, and some positive numbers. So I went ahead and picked -2, -1, 0, 1, 2 to give me an idea what it works out. So a lot of times I won't start with the negatives, especially if I'm not very confident in my negative exponents. So I might start with these ones down here. So 2 to the 0th power. Well, a number besides 0 to the 0th power is 1. 2 to the first power is 2. 2 to the second power is 4. Now, negative exponents, if you remember, a negative exponent, what it does is it moves it from the numerator to the denominator. So now I'm going to take this here, and it forces that to go to the denominator. So now I have 1 over 2 squared, which is 1/4. 2 to the negative first is 1 over 2, or if you plug it into the calculator, you're going to get decimals, so 0.5 and 0.25. So when I graph these, I probably don't have a quarter here, but I kind of have a half, 0, 1, 1, 2, 2, 4, and you can kind of see this is going to go up. So when they ask you to graph exponential functions, make sure you pick values that you can handle. You know, typically a few negatives, 0, a few positives, and plug them in. Now, logarithmic functions. Now, these are the inverses of exponential. So if x equals b to the y equals log base b of x. Okay, so this is always our exponent. What's going to happen here? So graph y equals log 2 of x. Now, these are very specific values that I picked. I don't just pick individual ones. I don't pick, like 3 and 5 and 7. I actually pick, for my x, I pick values that are multiples of powers of 2. So 2, 4, 8, 16, 1, a half, a fourth, and none of these values can be negative. Okay, so these are not going to be negative values. So when you're dealing with log, you're only picking positive values. So that makes it kind of nice. So I did pick 1/8, 1/4, 1/2, 1, 2, 4, 8, just to kind of give you an idea of what this does. So when I write this up here, this becomes, on this one, this becomes y equals log base 2 of 8. So this is really saying 2 to what power gives me 8. So 2 to the 3rd power gives me 8 because this is giving me my powers. 2 to what power gives me 4. 2 to what power gives me 2. 1. 2 to what power gives me 1. 0. A half is -1. A fourth is -2. -3. So we come here. So our log function is here on the right side of our graph. It is only dealing with the positive values there. Now, the last thing we're going to talk about is quadratics. Okay, I'm going to erase my board here. So a quadratic, if you remember, a quadratic is ax squared plus bx plus c. Okay, and that's going to give us some kind of parabola here. Okay, so the first thing is my vertex. Okay, so my vertex is going to be -b over 2a, comma, and if I were to say that this is equal to f of x, right, so this is function notation, what I'm going to do is I'm going to take this value and plug it in. So f of -b over 2a. So I'm just going to take that and plug it in, okay? So when we're graphing parabolas, what we want to do is we want to find that vertex first. Okay, so we need to find A, B, and C. So if I have y equals x squared minus 2x minus 3, I want to find those values. So really make sure that you understand that the vertex is probably the most important point on our parabola. Everything off of that is now symmetric. So if you remember back to your algebra, they're going to be symmetric. So 1 unit to the right of my vertex is the same as 1 unit to the left of my vertex. It has to be that way so these can match up. So here's my item here. Well, the number in front of x squared is a, this is b, and this is c. So now if I want to find my x coordinate, I'm going to go negative b over 2a. So that's negative negative 2 over 2 times 1, which gives me 1. Okay, so now I have an x coordinate of 1. Now if I want to find my y coordinate, I'm going to plug 1 in. So y equals 1 squared minus 2 times 1 minus 3, which gives me 1 minus 2 minus 3, which is negative 4. There's my vertex. So now if I come here and I graph 1, 2, 3, 4, 5, 1. Okay, so I'm going to plot 1, negative 4. So 1, negative 4. There's my vertex. Now to find some other points, I'm just going to pick values to the right and left of negative of 1. Okay, so I might pick 2. I pick 2 and I plug it in here. So I want to find 2 squared minus 2 times 2 minus 3, which is going to give me negative 3. So at 2, I'm at negative 3. Now if I plug in 0, I get 0 squared minus 2 times 0 minus 3, which is also negative 3. I actually now have 3 values. I have my vertex, which I have to find, and then I have a value on the right of it and a value on the left of it. So I can now graph this and get a good idea of what this is going to look like. Okay. Now, when we're modeling information, a lot of times they'll tell us what it's going to model into. So a lot of times they might say, well, you know, we're going to look at a punter punting the ball. Well, is a punter punting the ball look like this, where it goes on forever and ever? Is it going to be a log function that comes like this? It's going to flatten out and be horizontal? No, it's going to go up and then come back down. So we're going to use a quadratic. So these are a lot of the different ways that we can model information. And a lot of times we're looking at, how do I graph it? Here's my model. How do I graph it? Okay, so it's very important that we understand a lot of times what we're looking at is picking values and plugging them in. Okay.